Okay, guys, so the first thing we'll need to do is look at our ruler, okay? We're going to look at our ruler. When we're looking at our ruler, we're going to be using the small numbers, okay? The centimeters and millimeters side, super tiny, okay? Whenever we're measuring with a ruler, we're measuring at the first tick mark, not at the tip of the ruler. So when we're measuring with a ruler, we're measuring in that first line there, not at the tip of the ruler. The reason why is because no ruler is the same size after the tick mark. And so you want to make sure that you're starting your measuring at that first tick mark. That's 0 centimeters. Okay? So today what we're going to be doing is we're going to be launching our rubber band at 5 or 4 different lengths. We're going to be pulling it back 12 centimeters, then 18 centimeters, 24, and 30, and we're going to launch it. We want to see if the amount of pullback that we use affects how far our rubber band travels when we let it go. Valerie, go ahead and unmute yourself and tell me what you need.
Yes, ma'am. We do have a Parker do have a ruler, but it doesn't measure in centimeters.
Okay, so you'll just be paying attention with us today. Okay, so what we're going to do today, let me turn my computer around. Hi, can you hear me? Give me a thumbs up if you can hear me. Okay, so what we're going to be doing today, Valerie, go ahead and put your hand down. What we're going to be doing today is launching our rubber band at 4 different lengths. The first length we're supposed to measure, according to our table that we drew, our chart, is to pull our rubber band back 12 centimeters. So I'm going to pull it back and stop it at the 12 centimeter mark. Okay, so I can now put my ruler down because I know how far 12 centimeters is. And then you launch it. Make sure you don't move from your spot when you launch it, because now you're going to want to measure on the ground how many centimeters your rubber band traveled. An entire ruler is 30 centimeters long, or at least mine is. So I'm going to, where my foot is, measuring where my foot is, I'm going to measure from that point with my ruler, starting at my foot, and I'm going to measure how many centimeters that rubber band traveled from my foot. You do that too. 30, 60, 63 centimeters. So on my chart, when I stretched my rubber band, oops, when I stretched my rubber band 12 centimeters, it traveled 63 centimeters from my foot. Story, go ahead and unmute yourself and tell me what you need.
When I measured mine, I got like 196 centimeters.
That's okay. That's okay.
Okay.
Yep.
Just making sure.
Make sure you write it down on your chart. Okay. Then We're going to do the same thing again. But this time we're going to pull our rubber band back a little bit farther. Instead of at the 12 centimeter mark, we're going to pull it back to the 18 centimeter mark. We're really stretching it. So let's pull it back to 18. Remember, I can remove my ruler now. Oops, not yet. I can remove my ruler now because I know how far 18 centimeters is. I'm going to launch it. Okay? And so when I launched it, it traveled a little bit farther this time. Story, do you still have a... Henry, do you have a question?
Okay, so I wonder how far the rubber band goes if I pull it back 18 centimeters long.
That's what we're about to figure out. Go ahead and
Like
mute
this.
yourself. Go ahead and mute yourself and try it out. McKenna, go ahead and unmute yourself and tell us what you need. I can't hear you, McKenna. Maybe you should try later on. Oh, try now.
My rubber band won't stretch back that far.
Okay, so you'll just have to write down the numbers that I write down. Reese, go ahead and unmute yourself and tell me what you need.
I was going to say the same thing, that mine doesn't stretch.
You'll just write down the numbers that I have. Monte,
Okay.
go ahead and unmute yourself and tell me what you need.
Will this rubber band work?
It's already a little bit stretched out. So no, that's a little bit too big, but that's super cool. Chris, go ahead and unmute yourself and tell me what you need.
So what do we do if we don't have a rubber band? Do we just write down the numbers you have?
Yes, sir.
All right.
Okay. So now this is the hard part. Now I have to measure how far it traveled. Remember, we're measuring it with the small numbers, not the large numbers. The large numbers are in inches. This is in centimeters. Okay. So I'm going to go ahead and measure. Remember, from my foot where I launched, I'm going to measure 30, 60, 90, good night, 94 centimeters. So when I stretch my rubber band back, 18 centimeters, 94 centimeters is how far it traveled. Give me a second, guys. I'm sorry. There we go. Okay. Go ahead and write down your data. I'm seeing a pattern happen here. Now, while I've only had 2 tries, I'm seeing a pattern happen here. The farther I pull my rubber band back, I stretch it, the further it travels. I wonder if it makes it true then that I get what I give. In other words, the energy I put in is what I get back. Energy is constantly transforming. I'll give you a second to finish writing that down. And now let's do our next trial. I'm now going to pull my rubber band back. 24 centimeters. So on my ruler, I'm pulling this rubber band super far. So remember, we're starting from that tick mark, pulling it all the way back to the 24 mark. Wow. So now I know how far 24 meters is, and I can launch it. It traveled super far. So now I'm going to measure it. You should too. 30, 60, 90, 120, 150, and 67. 167. That time it traveled 167 centimeters. And now let's do our last launch. So now we're going to pull it back the entire length of the ruler. So we're going to start it at that first tick mark. And we're going to pull it all the way back to the length of my ruler. Okay? 30 inches. Let's see how far it goes. Let's get to measuring. From my foot, 30, 60, 90, 120, 150, 180, 205 centimeters. So, under our chart, let's write our conclusion. What does the data tell us? When I say the word data, that's a very scientific word for information. What numbers I wrote down in my chart. Okay, so what does that data tell us? Someone turn on your mic and you tell me, what would you say for that sentence? What does the data tell us?
All right, next. Number 5. Let's count.
Marley, go ahead and answer the question, sweetie.
That when when the distance when the rubber band travels is going from 63 to 205, so it's going from lowest to highest.
Yeah. So someone put that Marley's right around the right corner. Someone tell me what's happening there. Is there a relationship between how far don't talk while I am. Is there a relationship between how far I stretch it and the distance it travels? Chris, unmute yourself and let us know.
The more you stretch the rubber band, the harder it gets. Like
Very
30.
good. Everyone can go ahead and put their hands down. So here's what we should be writing. For the rubber band, is stretched more it travels. This is a, sorry y'all, this is a perfect example, babies. This is a perfect example of the law of conservation of energy. Okay, the more potential, elastic potential energy I put into the rubber band, the more kinetic energy I saw. The least amount of elastic potential energy I used, the least amount of kinetic energy I was able to see there. You want to go ahead and write this down? Please make sure you have yourself muted. Ms. Neville's about to go on. Okay, go ahead, take some time and put your rubber bands away, put your ruler away, have your notebook out and your pencils. Okay, so I'm going to share my screen with you. Our new heading for our notes today, we're going to begin speaking about some other types of energy. Today. We've spent a lot of time with potential and kinetic, as we should. Those are some of the more difficult ones to understand. So when we're talking about other types of energy, let's write down in our notes types of energy. Types of energy. And we're going to start talking about the first one, thermal energy. What actually happens with thermal energy. If your screen went black for a second, give it a second. It'll go back to the notes in a minute. Types of energy. And we're going to begin discussing Okay, so the first energy type we're going to start talking about today is thermal energy. Thermal energy. It's important for us to answer the question, how does thermal energy cause particles or atoms to behave? You saw this in one of our videos, but I wanted to make sure, based on some of your answers you were putting in on Schoology, that you made this clear. So I wanted to do an activity with you. If you see my face in the little side of the screen, that's perfect. Put up 2 fists like this. And as you can see in our picture, if our fists represented atoms, they would be really close together. This is what a cold piece of metal, the atoms of a cold piece of metal, look like. But if I start to heat up that metal, the particles will begin to separate, to move apart, and move faster. They're going to move apart and move faster, just like they would in a liquid. So it's important for us to understand that thermal energy causes particles or atoms to, 1, spread apart, and 2, move faster. It causes those particles to spread apart and move faster. And that's what we see happening here. So this is what I've always done in my classroom with my kids, and this is what we would do together if you were in my classroom face to face with me. Cold, warm, hot. Yeah, those particles spread out so much, they spread apart and move faster. Do that with your fists. Don't hit yourself. So that's what those particles, that's how thermal energy causes particles to behave. It's also important for us to know, the last thing we'll write down today, is that when we're talking about thermal energy, it's really important that we also discuss chemical energy. Raise your hand. How many of you have ever been to a bonfire where you've heard someone say, oops, we got to feed the fire? You ever heard that? We've got to feed the fire. That's because, if you can't see the notes, it'll give it a second. That's because chemical energy is feeding that fire. Yes, guys, chemical energy is feeding, that fire. Anytime we're talking about providing energy through chemicals, we're talking about chemical energy there. So a perfect picture for us to look at here . A perfect picture for us to look at here is a bonfire. Go ahead and draw a picture of a bonfire right now. It doesn't have to be as good as this picture here, okay? Just draw a simple fire. When I ask you what energy transformations I'm seeing here, when I'm talking about those energy transformations, I see chemical energy transforming into thermal energy and radiant energy. Someone put up their virtual hand so I can call on them. Why do I say chemical energy is transforming into thermal energy and radiant energy? In other words, where is chemical energy in this example? Where is thermal energy in this example? And where is radiant light energy in this example? Caden, go ahead and unmute yourself.
The fire is gonna turn. Well, the fire is chemical energy, and it's gonna turn into thermal energy.
Well, the fire is going to be thermal energy and radiant energy. I say, go ahead and mute yourself, please. I say that that fire is thermal and radiant energy because it's hot, it's a source of heat, and there's light coming from that fire. The chemical energy, we're going to write this in our notes as a star statement. The chemical energy are the logs, because the logs feed the fire. The logs feed the fire. I'm going to make this a little bit bigger for us. So we see chemical energy here as those logs are the food, the fuel for that fire. Go ahead and get this done. Now, I am not assigning, if you didn't finish getting these notes, the lesson is recorded and I'll put it up on Schoology as soon as class is over. I am not recording or I'm giving out any more new assignments. Most of you still have plenty left to do with all those 20s that are in your grades right now. So you need to focus on getting your missing assignments done. That's from lab safety as well. It's also going to be important. It's also going to be important for if you are still struggling with the energy types and you're done with all of your assignments, could you try making flashcards? Flashcards where on one side of the flashcard you write the energy, chemical energy, and on the other side of the flashcard you write examples of chemical energy. If you're still struggling with energy types, make flashcards and begin studying them. You have a 24-question test next Friday. So you need to spend Wednesday, Thursday, and Friday of this week studying, making flashcards, completing any old assignments, resubmitting things with low grades. You still have the ability to do that. If you are done with class for the day, if you don't have any questions for me, please click the red phone. If you do have questions for me, please stay online.
What is 6?
Bye.
Bye.
Henry, go ahead and ask your question.
Okay, so I have a dentist appointment at 3 p.m. today.
Henry, how about you email me what your question is, okay?
Okay.
Corey, go ahead and ask your question. All right, anybody who is left over, please email me your questions. I have to get to my second class. Everybody who's here still, please email me your questions. I have to get to my second class. Please click the red phone.
Bye, Miss Neville.
Bye, Marlene.
Yes, you said to make flashcards.